Okay, so we have a triangle. We have actually we have an electrical circuit, and we know a couple things about it. We know that we've taken the resistance of it, and it has 20 ohms of pure resistance, and that it has a piece of equipment on it that is stamped 130 volts, 21.2 millihenries, and we know that it's supplied by 120 volts. So what can we figure out from this? First of all, can we figure out the X sub L? We can figure out the X sub L, can't we?
60 hertz?
Well,
60 hertz?
what's our formula for X sub L?
2 pi FL.
X sub L
Is equal to 2 pi FL.
equal to 2 pi, oops, need to insert a symbol there. Where is pi? That's the ugliest pi I've ever seen. 2 pi FL. And in this case, we know that that is
377.
We're going to call this 377, and we have times, I've lost that now. We'll just make it a little x. How's that? 377 times 21.2, except it's not 21.2, it's actually it's 0.0212. Yes, sir.
377 frequency? You didn't put the multiplication sign.
Hang on. Where did I get 377? Where were you on the two lectures where we talked about it? We talked about this 2 different times. 2 pi FL here in the United States. 2, that's a number. Pi is 3.14. F, here in the United States, the frequency is 60 cycles per second. Okay, so 2 times pi times 60 is what? 375.9 or something like that? 376.89 or something like that. Do the multiplication. Huh? 376.99. That's close enough to 377. 2 pi FL. So what is, now wait a minute. You know what, I gotta go get my calculator. Ow. Even though I did this. I'm hoping that 0.0212 times 377 is what? Okay. 377 times 0.0212 is equal to 7.999. Okay. Okay, so we're going to say that the 7.99.24 is going to come out to 8 ohms. We're going to round up just very slightly. I'm going to call this 8 ohms. So if we call this 8 ohms, we would then, our very first question says that we want to find the phase angle. So to find the phase angle, all we have to do is hit second function tangent because we have the tangent, right? The tangent is 8 over 20. So we're just going to put in second function tangent, 8 divided by 20. That gives us an angle of 21.8 degrees. Is that correct? Okay. So that's our first answer, 21.8 degrees. Then our second question says, what is the power factor? Well, we know that the power factor is the cosine of that angle. Well, there's our angle right there, 21.8. So let's just hit cosine, second function answer, enter, and we have the cosine of that angle, and the cosine is 0.928476691. And if we multiply that times 100 to get a percentage, we get 92.84%. Does everybody agree with that? 92.84 degrees, percent. That's our power factor. So now we know that this circuit is turning 92.8%. It's a fairly efficient circuit, in other words, of its incoming power into true power. And I think that leads us into our next question. No, what is the circuit current? So now we have a couple things. Or do we? We need to find the current, don't we? We know our impedance, or do we? No, we don't. But now we have a cosine of this thing, right? The cosine of this is equal to, which is 0.9228, 0.9284, sorry. And that's equal to what? A over H, right? Which one of those do we know? Do we have the A? We do, right?
Yeah.
Okay, so we know that we
It's 10
can...
o'clock.
Thank you. We know that if we take 20 and divide by second function answer, in other words, the cosine, that we'll get 21.25. And that is our hypotenuse. 21.25 is our impedance, is it not? Or 21.54? I'm sorry, 21.54. 21.54 ohms. So now we know our impedance is 21.54 ohms. So now that we have that, we can take 120 and divide that by 21.54 ohms, and that'll give us our current, right? So just put in 120 divided by second function answer, enter. And we get 5.57 amps. Anybody see that? Not see that? Now, we're going to want our apparent power next, aren't we? So while we're here, we've got our 5.57 in a long, long number. We're going to multiply that times 120, and what will that give us? Our total apparent power, which is 668.5 VAs, volt amps. All right. So now, have we found a new answer? We did find the circuit current, which was 5.57 amps. And then it says, what is the impedance of this circuit? We already found that. That was 21.54. What is the apparent power of this circuit? And the apparent power, we just multiplied up and got that, 668. Then the next question is, what is the true power? So we're going to come over here and we're going to put our 668 over here. And down here we have an unknown. We don't know the side adjustment, but we don't know the side adjustment, but we do know the cosine, right? And the cosine is what? In this case, yeah, that's right, 0.91. So the cosine is equal to 0.9284. I'm assuming that's correct. 284,76691, and so on. And that's equal to what? Oh hell, another hour. Now what are we looking for? We're looking for the adjacent. We know the hypotenuse, don't we? What is our hypotenuse? 660, 8.5. So now we have three solid numbers and one variable. We have 0.9284 is equal to A over 668.6. And we can see that if we just multiply both sides by 668.6, we wind up with 668.5 times 0.9284, and that's going to be equal to our side adjacent, or our true power. So we can see that we just multiply this times 0.9284, and we wind up with 620.6. Is that VAs?
Watts.
Is that VARs?
Watts.
It's watts. Very good. Okay, so now you can see that we've done this whole darn problem, and how many times did we hit erase? None. None. Okay. Let's change some of these things on this whiteboard, and let's do our second problem. Okay, so now we have another problem, and we have a 10 ohm resistance and a coil, and the current flow in the circuit is 9 amps and the supplied voltage is 120 volts. So we can plug these things in. Now we need to find the impedance first of all, right? Because that'll give us an angle at least, right? So if we just divide 120 by 9, that'll give us our total impedance, right? Okay, so wait a minute. What function is that? Well, let's put that in first. 120 divided by 9 is 13.3333. Now, 0.3333. And if I could, I'd put a line over the first two threes just to indicate that that's a continuous number. But we'll just have to remember that. So that's my total impedance. So if I've got my total impedance and I've got my resistance, what function do I have? That's the cosine, right? This is the side adjacent. This is the hypotenuse. So if I just say second function cosine, what angle has this A over H, right? 10 divided by 13.333. I find that it's 41.409 degrees. 409 degrees. So I can find a degree symbol. I don't think so. Oh, darn.
What number did you guess? 0.75 up?
41.409 degrees. Alrighty, good to hear. So,
Can you go through it? Let me know, how did you get the 41.49? Because I did 10 divided by 120. 3 and I got a different number.
so the cosine of the angle is 10 divided by 13.33. So in your calculator you can push in second function cosine, 10 divided by 13.33333, and it'll tell you that it's 41.409 degrees. So that's our angle. And one of our questions is, oh, we want the inductive reactance first. Well, first we have to find the angle, because now that we have an angle, because we're looking for the side opposite, right? We want to find the side opposite. Well, which function has the hypotenuse, which we have, and the side opposite? That's the sine, right? So if we put in sine, second function answer, It'll tell us the sine of this angle. And the sine of this angle is 0.661437 and so on. And that's equal to what? Oh hell. And if we put in that right here, we have 0.66143 and so on is equal to, and actually that's 0 point. We know that that's equal to the opposite divided by 13.33, right? So if we just multiply 13.33 times both sides, we'll get times 0.66143 and that whole long number that happens to be still on our calculator. So we're just going to hit times 13.3333 and a few extra threes. And we'll get 8.819 ohms. 819 ohms. Now, why is that important? Because now, what does it say? It says find the X sub L. What's the reactance of the coil? What is the phase angle? We already know the phase angle. The cosine of 41.409. If you just divide 10 by 13.33, what do we get? Cosine of 41.4074 is 75% on the money, right? Wonder how that happened. So, let's go back. All we need to find now is our X sub L, right? So now, if we can get back into this thing, I hope. No, I guess not. I don't know how, but... So anyway, let's just go here and start a new one. How's that? So our 8.819 ohms our ohm symbol. Should be down at the bottom, right? Last one almost.
No, that's pi. Oh, it's in the middle. Third line in the middle, right there.
There we go. Thank you.
But they got a better pi for you down there at the end. Like that one.
You're right. I don't like that one. Okay, so that's equal to 2 pi FL, right? 2 pi FL. Well, let's call that 377 because that's our shortcut number. Times what? Our L, yeah. And that's the question. What is our inductive reactance, right? So if we want to get the 377 off both those sides, we can just divide both sides by 377, can't we? Well, I have my 8.819 in my calculator, so I'm going to just divide by 377. And now it says that L is equal to 0.02339 and so on. And if we put this in proper engineering notation, we'll find that we have 23.39 or just 0.3, 39 or 34. Millihenries, right? Everybody see that? Any questions now? Good deal. All right.